I think we're ready to go. Good evening and welcome to Tap Chat, a virtual live open house with the Cascade Groundwater Alliance. And that's a partnership between the City of Gresham and the Rockwood Water People's Utility District. The Cascade Groundwater Alliance was formed to expand our groundwater system by 2026. And we want to thank you for being here and participating tonight. Just so you'll know, we're going to be recording Tap Chat to make available for those who couldn't make it tonight for this 1 hour long presentation. To give you a little background on what's going to happen tonight, tonight's presentation will provide information about our current water supply, why we are expanding our groundwater supply, how groundwater works, and the timeline for this project. This will be followed by a question and answer session, and we will end our event promptly at 7 p.m. as we advertised. Once we've completed our question and answer session, I'll wrap up Tap Chat for the evening. The project website address will be shared on YouTube in the chat feature, just so you'll know. So get comfortable, settle in as we begin our Tap Chat. So my name is Tam Driscoll, and I'll be your host for the evening. I'm a longtime employee with the City of Gresham, having hit my 25th anniversary. I've worn many hats at the city, including tonight's host and facilitator. And now I'm going to go on to our panel, who have a combined 70 years of experience in the water profession. First, we're going to start with Mike Whiteley. Mike has two titles, Water Resource Manager, as well as the Groundwater Project Manager. Mike has extensive practice in the water industry with over 30 years of experience. Welcome, Mike. Our next panelist is Carrie Duncan. She's the General Manager of Rockwood Water People's Utility District, which we'll refer to as Rockwood throughout this presentation. Carrie will be providing oversight and support to the district engineers on the groundwater project. Also of note, Carrie is also a licensed water treatment 4 and water distribution 3 operator in the state of Oregon. Carrie brings with her 21 years of experience in the water profession. Welcome, Carrie. Now, our third and final panelist is Jason Brandstetter. Jason is a senior engineer at the City of Gresham. He has over 20 years of experience in the water industry. Jason's role in the groundwater project is to oversee the design and construction of the system improvements in partnership with Rockwood's engineering staff. Welcome, Jason. So I'd like to thank our three panelists in advance, and we appreciate you being here tonight. So now to kick off our Tap Chat, we're going to have Mike Whiteley start the presentation. Take it away, Mike.
Thanks, Tam, and thanks to all of you for taking the time to learn about our newly formed Cascade Groundwater Alliance between the Rockwood Water District and the City of Gresham. I'm going to start tonight's presentation with some background of our two water systems and how we ended up developing the Groundwater Alliance. The City of Gresham and Rockwood Water have been wholesale customers of Portland for many years. As a wholesale customer, we both purchase a majority of our water we serve from the City of Portland. Gresham has been a purchaser from Portland since 1912 and Rockwood Water since 1945. Portland serves its customers and wholesalers from two main sources of supply. The majority of water is served through the Bull Run system, and in times of higher demand, the backup system is a groundwater well field. Shown here is the Columbia South Shore well field. Every summer, Portland taps into the groundwater supply to help supply the peak demands during the hot summer months. Their groundwater is supplied by the same aquifer that we will be developing, so Gresham and Rockwood residents have been drinking this groundwater source for many years. The Bull Run watershed supply is a surface water source that has been one of the few surface water sources in the country that had an exemption to remain unfiltered. It's because of the purity of the Bull Run watershed. However, in early 2017, Portland started getting some small detections of cryptosporidium, which is a parasite that can cause illness. These small amounts of cryptosporidium hits were becoming more frequent, and ultimately the EPA removed the variants from Portland to remain unfiltered. And then later that year, Portland City Council voted to install a new treatment plant. So Portland ended up providing the wholesale customers estimated rates with the impact of the new treatment plant would have to our rates. By 2030, it showed that our wholesale water rates would more than triple. With that information, Gresham and Rockwood developed a groundwater development master plan to determine what the cost and timeline would be to develop our groundwater supply to become independent from Portland. These cost estimates showed that the long-term rates would be significantly less if we developed our own groundwater system. Late last year, Gresham City Council approved an agreement with the Rockwood Water District to develop our shared groundwater supply and to become independent from Portland. Next slide, please. So what makes up our Groundwater Alliance? Well, Gresham serves approximately 74,000 people, and Rockwood serves approximately 63,000 or 66,000. Rockwood actually serves about half the area within the city boundaries, and some of you may live within Gresham city boundaries, but are served by Rockwood Water. Both systems are currently Portland wholesale customers, as I mentioned before. Both Rockwood and Gresham have developed their own groundwater sources. Rockwood has 2 production wells and Gresham has 1 production well. We are both exploring several locations for future wells, which Jason will be talking about later in this presentation. In the early 2000s, Gresham and Rockwood made an agreement for Gresham to actually buy in to the Rockwood groundwater system. And now both agencies jointly own the reservoir, pump station, and treatment system at the Rockwood facilities. Excuse me. An interesting note is that Rockwood does have a 42 million gallon per day water right. And by agreement, Rockwood has granted Gresham the use of 18 million gallons per day of that water right. The 42 million gallons per day will be enough capacity to serve both systems far into the future. Next slide. So now let's compare the options of staying on Portland or developing our shared water groundwater facility. First, let's talk about continuing with Portland. As I said before, wholesale water rates are expected to more than triple by 2030. Portland's system also has some aging infrastructure, which to date has not shown the need for replacement, but when and if it does, it's going to be very costly to replace. Due to the cost of the water treatment plant and future expenses to operate the Bull Run system, our systems, Gresham and Rockwood, will see higher long-term water rates. Looking at our independent groundwater supply, Gresham and Rockwood have been one of the nice things we have lately is that Gresham and Rockwood have been accepted to apply for an EPA loan with very good terms, including interest rates and payback timeline. This is going to allow the city and the district to keep rates much lower than had we stayed as a wholesale customer. Because we will have groundwater wells throughout the city and have redundant transmission mains, the groundwater system will become more seismically resilient. The Bull Run system is also more vulnerable to forest fires and potential even volcanic activity. Having our own water source will provide our citizens and our industrial customers with a more consistent water quality. Many of our larger industrial customers need to adjust their water treatment systems throughout the year because of different water quality that we're delivering. Sometimes it might be purely Bull Run, other times it might be a water quality with Bull Run and a mix of the Portland South Shore groundwater system. Sometimes it might be in all three. It might be the Bull Run, the Portland groundwater, and our own groundwater supply. So they're constantly having to change their treatment systems to match what the water quality that they need for their industry. Another benefit is having our own water source will allow for more local control. Right now, wholesale customers may give recommendations. However, ultimately, Portland is the final decision maker in how they operate, treat, and manage their water supply. Additionally, we have our own source of supply. Having our own source of supply will add resiliency to the whole region. If we have water to spare, we can help other agencies in our region. So I'm now going to turn it over to Carrie to discuss our groundwater source.
Thank you, Mike. All right, I'm going to take some time to provide background on what groundwater is, how it gets there, and why our groundwater source is such an excellent choice for our communities. Groundwater is water that fills the spaces between soil particles and fractured rock in geological formations beneath the ground's surface. Although we never see it, groundwater accounts for 99% of the world's liquid fresh water, and about half of the US population drinks groundwater. An aquifer is a water-bearing formation that has enough connected spaces to allow groundwater to flow to wells or springs. Aquifers can be replenished, recharged by rain, snowmelt, and surface water bodies, like some of the images you see here. And depending on local conditions, which I'll talk about in a little bit, an aquifer might discharge to surface water, or it might recharge from surface water. Can I have the next slide? Oh, there it is, thanks. So our groundwater, what you see here is an image of the groundwater aquifer. The aquifer that supplies our groundwater is part of the Portland Basin, which covers about 1,000 square miles in Oregon and Washington. You can see the image to your right is quite a large image, and you're going up well into Washington and well down south. The Portland Basin aquifers were formed by deposition of sediments that filled the basin over millions of years. Geologists call them basin fill aquifers. Our groundwater comes from the sand and gravel aquifer, or SGA, you'll hear me refer to that term, which is the deepest and oldest aquifer in the Portland Basin aquifer system. The SGA is shown in green. You can see in the image to your left, which is a zoomed in image, that it seems to disappear somewhere beneath Gresham. That's because the USGS doesn't have enough information when they created this map. What we have found by drilling test wells last year, in fact, you can see the blue dot to the south is the southernmost test well that we drilled. We found that the SGA is present in that location. It's just much deeper to the south area. This illustrates a good reason for drilling test wells when planning for a new well site. The top of the aquifer is found at depths of between 450 feet to more than 1,400 feet below the surface at the locations of the existing and planned Gresham Rockwood Water groundwater supply wells. And those are the depths that and deeper that we are drilling our wells. Can I have the next slide? All right, this figure shows a simplified cross-section of the aquifer system in the area of Rockwood's main supply wells and Gresham's main supply wells. The different deposition events that happened over millions of years in the Portland Basin created a layered aquifer system. And you can see from the top down to the bottom of this image, several different layers, each labeled. You can see here that there are three major aquifers separated by two confining units. You have the Troutdale sandstone aquifer and the sand and gravel aquifer, and then up at the very top, the Troutdale gravel aquifer. So the confining units, oh, not quite ready, thanks. The confining unit is a layer of very fine sediments, mainly silt and clay, that functions as a barrier between these aquifers. This is a protective barrier for our water. These two confining units above the SGA are extremely important because they play a major role in protecting our groundwater from contamination that could occur above the ground. Next slide. So is our groundwater use sustainable? The Portland Basin aquifer system captures recharge throughout its 1,000 square mile area, and that recharge contributes to the regional groundwater flow that recharges the SGA. Under natural conditions, most of the recharge to the SGA comes from the southern and eastern margins of the basin, flowing north towards the Columbia River. You can see in the image to your left arrows from south, even south of Happy Valley, flowing north in towards Gresham and Rockwood area. And this is the direction that this aquifer is traveling very slowly. Under pumping conditions, the SGA can also receive recharge from the direction of the Columbia River in areas where confining units are thin or absent, such as near Blue Lake. The recharge from the Columbia River maintains the aquifer so that ambient groundwater levels don't drop below the river level. So this helps that aquifer remain charged at all times. Next slide. Okay, so is our groundwater safe from contamination? The SGA, sand and gravel aquifer, is naturally protected from contamination. First, the basin sediments function as a natural filter. They remove particulate contaminants and microbes, such as bacteria and pathogens that are common in surface water. Second, many of the most common surface contaminants from industry and stormwater actually bind to the organic matter in surface soils. Finally, the confining units are effective barriers to flow from above. This is important. Each confining unit is 50 to 200 feet thick across our service areas, making the sand and gravel aquifer the least vulnerable aquifer in the basin. This is a very protected layer and a very protected water resource. In addition, to these natural protections, our Wellhead Protection Program works with local businesses to reduce the risk of contamination from spills or waste disposal. And I'm very proud to say that the Well Protection Program, which Gresham and Rockwood jointly sponsor, just won a national award from the American Waterworks Association. It's a very excellent program. Next slide. So let's talk a little bit about water quality parameters in the groundwater and what might be different from surface water. As we mentioned before, groundwater is naturally protected from bacteria and microbial contaminants. So we do not typically see some of the contaminants that you'll see in lakes and streams. Another different component is groundwater does tend to have a little higher mineral content. Things like calcium, magnesium, manganese, and iron can be found in groundwater at higher levels than in surface water, typically. The water hardness is a little bit higher than in the surface water, although this aquifer actually, in comparison to many groundwater sources, has relatively low hardness. It's 55 to 60 milligrams per liter based on our extensive testing, which is 3.5 grains per gallon. One of the most common water quality calls that I receive is what the grains per gallon is for my dishwasher. The 3.5 grains per gallon is still considered on the soft range, which means you don't need to add extra detergent, and you typically don't need a water softener for this level of hardness. The disinfectant residual, because we will be operating a smaller system than the large Portland system which operates, will be a little bit different as well. However, in general, you will see that the water quality is excellent and will not be very different from what we experience today. I do want to point out the manganese and iron are items that can cause discoloration or taste in the water. For this reason, we are installing a treatment system for those two components, which I'll talk about in the next slide. Go ahead and turn to the next. Thank you. So as part of our project, we are going to be installing a water treatment plant. These treatment systems are specialized just for the manganese and iron in the water. They help to remove those components. This is an image of our site, and the building in the left image is a building of the new treatment system. And you can see the image to the left has that system with the roof off, and the blue cylinders are filters, which are designed to remove manganese from the water. That will help the water to not have some taste issues, as well as aesthetic issues that sometimes occur with groundwater. Next slide. This is a picture of an operating treatment plant similar to what we have. This is from Clark County PUD. These are the manganese filters in the blue, and to the right is an on-site chlorine generation system, which is part of that treatment process. Next slide. This is just an image, a couple of images from our system. This is our current Cascade water reservoir, as well as a pump station. And some of this is equipment similar to what we will be building and expanding as part of our project. And now I'm going to pass this on to Jason Brandstetter, Senior Water Engineer with City of Gresham, to talk about the design and construction project.
Thank you, Carrie. And before I get started in my portion of the talk this evening, just wanted to remind folks that if you are watching our live stream on YouTube and you have questions about the materials here or about the Cascade groundwater system, that you can put those into the chat feature there on the YouTube screen. Moving on, we'll talk a little bit about the existing groundwater system that's jointly operated by the City of Gresham and Rockwood Water District. So since about 2008, 2009, we've had 3 wells. Wells number 3 and 4 are located at the Rockwood Water District offices, and Cascade well number 5 is located at fire station number 74. Those 3 wells all pump back for treatment. They're at Rockwood's district offices and then are delivered down the 30-inch groundwater transmission main that's connected to Rockwood's Bella Vista Reservoir and Gresham's Grandview Reservoir. This system is capable of delivering about 13 million gallons a day that's jointly shared between the 2 utilities. The primary restriction in the existing system is the capacity of that 30-inch groundwater transmission main. Next slide. So one of the key pieces of our future construction will be to construct an additional groundwater transmission pipeline that will allow us to significantly increase the capacity of our groundwater system. Additionally, we'll be drilling 2 additional wells, which will pump back to the central treatment facilities at the Rockwood District offices. And then we'll have 2 to 3 additional satellite well and treatment facilities, which will pump into the rest of the system. And as shown there, kind of coming back to focusing on the central system, the secondary groundwater transmission main will also deliver water to the Rockwood Bella Vista tank and the Gresham Grant Butte tank. Next slide, please. So our work in progress over the past year, we've completed some significant well drilling in anticipation of expanding the Cascade groundwater system. Cascade well number 7 at the 202nd site was completed, as well as the Cascade 9 drilling at Kirk Park. Rockwood also completed drilling of its groundwater well at its 141st site. And then the test well was completed at Gresham's Southwest Community Park site. Shown in the slide here, on the right-hand side is an auger drilling rig, which was used to complete the initial portion of the well hole. And then on the left is an aerial view of a mud rotary drill rig, which was used to complete the deeper portions of the groundwater wells. In the case of the Kirk Park well, we achieved a depth of about 800 feet below the ground surface. Next slide, please. So next phases in our construction, we're just kicking off the construction of kind of 3 major components of the expanded groundwater system. The construction of the new Cascade Reservoir number 2, which is a 6 million gallon pre-stressed concrete reservoir that'll be built at the Rockwood District offices. We're starting the construction on the well house for the Cascade well number 7, and then the pipelines which will connect Cascade well 7 back to Rockwood's district offices, and the initial portion of that secondary groundwater transmission main. So ultimately, when the system is all built out before 2025, we will have 8 total wells, up to 3 independent treatment sites, and we'll have expanded that existing system to a capacity of more than 25 million gallons per day, which will be more than enough to supply the demands of both Gresham and Rockwood. We are planning our construction to have everything complete and ready to be fully tested in the summer of 2025, completely ready to go live and be operational in 2026, when we'll be ready to get off of our connection from the city of Portland. And with that, I'll turn it back over to Tam for a summary and questions.
Great, thank you, Jason. I want to thank our panelists, Mike, Carrie, and Jason. We appreciate your overview. You guys did a great job of presenting some technical information to our audience. I'd like to kind of recap some highlights from your presentation. A big one, that this project will take over the next 5 years to complete the expansion of our groundwater system. So we're looking at 2026. Kind of a fact there, and several of our presenters touched on this. Did you know that Gresham and Rockwood already are drinking groundwater? And we are at about a 15 to 30% blended with Portland water during our peak summer demand when we have a lot of water usage. We're committed here to delivering you all groundwater that is safe, groundwater that is reliable, and then groundwater that is more affordable option for our community. And that's why we're pursuing this Cascade Groundwater Alliance. Also of note is that this is a historic partnership, this Cascade Groundwater Alliance, and we are going to deliver all of those benefits to you, our customer. So with that, I'm going to give you a little time check. I think we are right at 6:30, and we're going to go into our question and answer session. So as Jason mentioned, there is a chat feature in YouTube where you can type in any of your questions. We have questions we have received in advance of our presentation, which we asked when we advertised, and we also have received some questions from our viewers. And so I'm going to deliver our first question that we got and pose it to our panelists. And this comes from Kathy G. And she is asking, I remember that Cascade Corp caused pollution of the groundwater that needed to be remediated. How many other pollution sites are within our well field? ? And how many have been remediated? So I will put this question out there and see if one of our panelists would like to answer Kathy G's question.
So I cannot speak to the number of sites or the remediation, but I can speak specifically towards the testing of our aquifers. The vast majority of contamination that occurred in that well field was confined to the upper aquifers, leaving the sand and gravel aquifer protected. As you recall from the presentation earlier, I showed you the image where we had several protective confining layers before our deep sand and gravel aquifer. And so the contamination that Kathy talks about was in the upper, one of the upper aquifers. We do extensive monitoring at our wells, and we have never detected those contaminants in our groundwater.
Great. Thank you. Now I'm going to go to a couple of other questions we received. This one is, when Mount Hood melts, does that water become groundwater?
Would you like me to? Oh, I can take that one as well. We have snowpack on Mount Hood, and when it melts, we want to know, where does that water go? What I can tell you is that some of the water melts and flows into rivers and streams and becomes surface water. It flows across the surface. But a lot of that water, when it melts, will slowly percolate and infiltrate down, and it does become groundwater. So it is a combination. And aquifer recharge is an important factor in aquifer recharge is snowmelt.
Which also kind of leads to that whole sustainability piece as well, is that we have that recharge, and it does aid in that. So plus we are a wet region. I think that also helps. All right, maybe one of our other panelists here. We have, how is the project being paid for, and how will this affect water customer rates? And I presume this can also be in our partnership question of both. But it looks like Mike Whiteley has clicked off his mute button.
So I can tackle that one. I kind of mentioned that in my presentation, that we are looking at Gresham and Rockwood are independently securing their own financing for the projects. We're not one entity getting one lump sum. So Gresham is, however, we did apply for that EPA loan that I talked about earlier, generally known as WIFIA, which allows us to borrow 49% of the project cost at very low interest rates and long-term payback, which will allow us to manage the rates in the future. We're also looking, Gresham is also looking at other avenues to pay the other 51% of the project, which includes the state revolving loan fund and potentially other bonds or other issues.
Great, thanks. So essentially offsetting the overall cost so we don't put all of that burden onto our ratepayers, in a nutshell. This one kind of goes back to a similar question about kind of the pollutant risks. This question is, how do you protect groundwater? And I imagine the you could be both Gresham and Rockwood. And are there any pollutant risks to our groundwater system? And so maybe we could have an answer from Rockwood and then also our Gresham side.
Well, I can start with how we protect our groundwater system right now. I think Carrie mentioned it in her presentation that we do have an award-winning wellhead protection program. And that program started probably 10 or more years ago when we identified the area that our wells are recharging from. And went to businesses in those recharge areas and asked for compliance so that they would not be potentially endangering our groundwater aquifer. Yes, we do have 2 confining layers, but we don't want to take any chances on getting any surface water pollution down into our aquifer. And we will be expanding that groundwater or the wellhead protection plan as we add new groundwater sources. I envision right now about half the city is under the wellhead protection program. Potentially it could expand to the whole city at some point.
Thanks, Mike. And just to add to that, so what you're saying is wherever we have our wells, we have a wellhead protection so we can protect that kind of area where we have our water source. So, okay.
Right, we identified for each well where that well is being recharged from over a certain amount of time, and then that identifies our wellhead protection program area.
Great, thank you. All right, Carrie, do you want to address for Rockwood?
Yes, thank you. I'll add on to that. In addition to the great groundwater protection program that we have, another important way to protect our groundwater is to make sure we know what's in it. And we do very rigorous and frequent testing of our groundwater wells, as well as monitoring what's in that water, so that if we do know any potential contamination, we can detect it immediately and either make a plan to treat for it or remediate it. So testing is also an important element in groundwater protection.
Thank you, Carrie. We have another question. We're going to go back to our audience here. I want to thank, this is from PDXZ Man. This is a good question here. Well, they're all good. My family loves the taste of our water. Can we expect the taste of our water to change by changing the source?
So I can take that question. I think that for the majority of people, they're not going to notice a big change in taste. But as I mentioned in my presentation, there is a difference in mineral content. Some people, in fact, I'm one of them. I have a home well, and can't see my glass here, but I'm drinking well water, and I really like the taste of well water because I think that the minerals, the calcium in that water adds a little bit to that taste. But I think that some customers may notice a slight taste change to the water, but largely most people will not notice the difference.
And we already are drinking somewhat of a blended, especially in summer months. So we're, it's up to 30%. So we haven't, I think there's not a notable taste in that, but anyway, thank you, Carrie. That's good.
And I guess I'll also note that the typical negative flavors in groundwater typically come from iron and manganese, and those minerals are what we are treating for in our treatment plant. So we'll be removing those that typically result in an unusual taste or a metallic taste to people.
Great, thank you, Carrie. All right, we're going to go back to our advanced question here. This one is, will we be using Bull Run / Portland water? So I think what we're asking is, if we go onto groundwater, will there be any supplemental use at all, little or big, from Bull Run, Portland area water source?
So I can tackle that one. Our goal is to become fully independent from Portland, which means we would not be taking any portion of Portland water, with the exception of if we have an emergency. I think both systems are going to keep their emergency supply connection with Portland, so that if we do have an emergency, we're able to purchase water from Portland as a backup supply. But generally, when we're running the system, there will not be any will run in the system. There's one additional factor is that when we go to our own groundwater supply, we're going to be changing our disinfection system, and to intermingle Portland water with our water may create some issues. So we don't want to do that unless we absolutely have to in an emergency.
Thanks, Mike. All right, here's another sort of finance question about costs. Will partnering with Rockwood keep our costs down? I don't know who wants to tackle that one.
Well, I guess I can tackle that one too. Of course, when we partner with Rockwood, there's going to be economies of scale that we see that are going to help keep our costs down. But more importantly, we share the facilities, we share the expenses, we share, the water, and that in itself helps keep our water rates affordable.
Great, thanks. And this is another, thank you, Mike, another sort of cost finance that I think is on a lot of folks' mind. What if I'm concerned with paying my water bill? Is there any help or assistance? And I presume for their water bill.
Well, I know Gresham and I assume Rockwood would be also very sensitive to our customers that would need customer assistance, and we're going to either case, whether we stay with Portland or as we're doing now, developing our own source, there is going to be significant rate adjustments to be able to pay for those facilities. But we are aware that there are citizens in our city that would benefit from increased customer assistance. So we're looking at expanding our customer assistance program. And I'll let Carrie talk about Rockwood's.
Yeah, absolutely. Thanks, Mike and Tam. This last year with COVID has been a challenging year for a lot of our customers. Rockwood does offer a bill assistance program, and you can find information about that from our website, or if you call our Rockwood number, so that customers who are unable to pay their bill and who call for support can gain access and apply for the bill assistance program. And we certainly will continue that program on into the future.
Great, thank you, Carrie. Let's see. Here's another question, kind of a short one, but a big one. Is groundwater safe? And I know we've kind of touched on it in every one of your presentations, but as far as answering that question.
Certainly. What I can tell you is our groundwater, the groundwater in the aquifer and the source that we are using is safe. It meets all federal and state safe drinking water regulations, and our treatment process, which we are adding, will only improve that water. And so we're very confident that the water in the sand and gravel aquifer that we're using is safe and meets all safe drinking water regulations. But I'll note again, as we talked about, it's important to have a good groundwater protection program, a good testing program, and to make sure that we are continuing to protect that aquifer and we continue to make sure it stays safe long into the future.
Great, thank you, Carrie. One question, and we've talked about this in our presentation, there was the word of, seismic resiliency. So we know that we kind of live in an area that is prone to earthquake. Can one of our panelists address kind of the safety of our groundwater system in the terms of, in the event of a kind of a catastrophic event such as an earthquake, how that would sustain itself?
Sure, I can touch on that just briefly, Tam. Relative to seismic resilience, especially, if we're going to compare the groundwater system that we're developing to our existing connections to the Portland system, it's from an engineering standpoint, we have increased redundancy and increased resiliency available in the groundwater system, as all of it will have backup power supplies. And with the multiple well sites, if we were to lose one well site in the event of an earthquake, we have several others that will act as backups to provide reliable groundwater for our customers. And then with the development of additional transmission facilities, those pipelines are going to be built to current seismic standards, which pipelines which were built in previous generations would not have been built to those standards. So this system that we're constructing will be very resilient from an earthquake standpoint.
Jason, could you just kind of define for our viewers the term redundancy, what you're referring to there, just so we don't make just so folks will know?
Sure. Yeah, engineers, we like to not speak English all the time.
That's okay.
Redundancy, we like to having multiple of one item that can perform the same task. So in the event, like I said, with the wells, we're going to have multiple wells. Our pump station will have multiple pumps, multiple motors, which can move the water from one tank to another. With the pipelines, we're going to have two independent transmission pipelines. So for if one reason an earthquake compromised one of those pipeline facilities, the other would still be able to operate and perform the same task.
Nice job for an engineer. No, just kidding. That was a great job. I'm going to pose a question just in general to our panelists. We are roughly 12 minutes before we hit 7 o'clock. So I'd like to offer, first of all, our viewers, if you have any questions that you might want this panel to ask, please type those into the chat and they'll come to me eventually. But until then, is there anything, our three panelists, that perhaps you would like to touch on further, or that maybe you would like our viewers to have a better understanding of, that we have not had the opportunity to kind of elaborate on, that might be helpful for kind of an understanding of our groundwater system and what we can expect in the future?
Sure, Tam. I know we've touched on the our use of the aquifer and the safety of it, but I think it's really important to highlight that we are not the only ones that have been using this aquifer. Our neighbors to the west, Portland, has been using them, neighbors to the north, and even some of our local jurisdictions around us, Wood Village, Troutdale, Fairview, also use groundwater sources. So it's not a new concept to many of the area, but and again, we've been using the groundwater source for several years.
Thanks, Mike. Yeah, I think Carrie touched on it. Is it roughly, I'll see if I'm listening right and you can grade me later, but roughly over 99% of our kind of water source is the groundwater source, and over 50% of across the nation use some type of groundwater system. Are we getting a head nod? Am I anywhere close?
I think those are good good statistics. Yes. I guess the one thing I would like to touch on is, and I think that Mike discussed it, the importance of local ownership in our source water system. We are developing our own source of water, our own conveyance facilities. And so everything that provides water to the people in Rockwood and Gresham service areas will be owned and operated and completely controlled by Rockwood and Gresham and our publicly elected, board of directors and council. And so this is what's important is we're becoming owners of a system instead of reliant on a wholesale purchase. And so I think that I'd just like to emphasize that again, and the importance of our local water supply.
So could we equate that as from going from being a renter to a homeowner, essentially? Is that?
Yes, it is. It is. We're investing in an owned water supply, which will benefit us into the future.
That's great. We are now roughly 9 minutes out, and I'm going to check to see. I don't think we have any more questions from our viewers. Mike, Jason, and Carrie, any more to add? And if you don't, I don't want to have to necessarily put you guys on the spot. I think there are excellent questions. I think even for me as somebody who's well aware of this project, it really does help clarify kind of where we're going and what we're doing. So I appreciate that. And I hope our viewers found this information helpful. And with that, we may want to, let's see, wrap this up here. Anything else to add? We're going to hear going. I'm going to wrap it up by kind of just emphasizing, the safety of this groundwater, and that it is about efficiency, about keeping our costs down, about investing in this system. And I would add that the city of Gresham and Rockwood Water are leveraging our longstanding partnership to essentially build a regional water supply system that will be resilient, more affordable, and deliver consistent water quality to our residents. And that really is our commitment. And we're going to deliver that to you in your tap. How's that? So I want to say special thanks to our panelists, to Mike Whiteley, Jason Brandstetter, Carrie Duncan, for serving on this panel. I, again, want to reiterate, I hope our viewers found this helpful. I want to thank you all for tuning in tonight and watching our first ever Tap Chat. And with that, I want to say good night and go fill up a glass of water and drink. And that's it. So thank you very much.